In this tutorial, we're going to use a new Burp extension called AutoMapper to scan a web application and find out what the sitemap looks like and what kind of application vulnerabilities there are to be seen. We're going to use a popular site called WebGoat, running against a Docker image of that site. And WebGoat is nice because it's deliberately coded to be vulnerable to various kind of things like cross-site scripting and SQL injection, and it's a good demonstration tool to show when the attacks are working and what the evidence of those attacks looks like in various tools, including Burp. So the result we're going to try to create looks something like this. This is a finished AutoMapper run, pulling in results from the Venari scan engine, and on the right you see the issues, on the left you see the sitemap. I will point out that to see the issues in that top right panel, you do have to have the Burp Professional Edition. Here is the same set of results in the Venari Community Edition user interface. You have to be running Venari while AutoMapper is running, but you don't have to be interacting with the UI. This is just something we're going to look at after the fact to compare and correlate what Burp demonstrates in its issues panel and how Venari shows the same information in its findings panel. The goals of the tutorial are to configure Venari to work with Burp in the first place, to run the AutoMapper extension in Burp and start the site mapping and kind of watch that go for a while. We'll fast forward to the end and explore the finished issues that happen at the end of the scan, which takes about 50 minutes. We'll understand some advanced DOM-based XSS testing that really makes the power of these tools running together really shine. There's a lot of evidence that you can see being pushed into Burp, and also which can be looked at in Venari to demonstrate that DOM-based XSS is actually happening. So we're gonna eliminate false positives from the equation. And the last thing we'll do, as mentioned, is we'll correlate everything we found in Burp and we'll look at it in Venari and show the complementary nature of these two tools. So let's get started. You can download Venari Community Edition for free. Just go to the assertsecurity.io homepage and click the Venari Community Edition button. You'll be given a choice of whether you want to download for Windows, Linux, or Mac. It runs equally well on all three. At the time of this recording, the Burp App Store does not have the extension available yet. Approval for that is pending. In the meantime, you can download the jar file from the Assert Security homepage. So just make sure inside Burp that you have this extension loaded and enabled. Before starting Burp and running the AutoMapper, first Venari has to be running. So I'm going to create a new application. It's for WebGoat, and I've already created that application, but I'm going to do another one here just to go through the full steps. You give it the application name, you give it the URL. This is for a local Docker hosted version of WebGoat that I have running on this machine. And then you put in user credentials. So I created a user, Joe Blow, with a simple password. I'm going to turn off discovery templates because we're actually going to do both a crawl and an exploit. So at this point I click OK. And what we notice in the middle is we've created a job template which is just called Burp Extension. And I'm going to drill into this a little bit. It's optional to edit this at this point. You can use this template just the way it is. I'm just going to point out some additional choices that you can make. We have these rules that drive the exploit engine, and as this screen comes in, you're going to see a lot of these are unchecked. We have two categories: inspection rules and fuzz rules, and if you so choose, you could do a more thorough scan. For the example that I've already done that we're going to review later, I did turn on all of the rules, so this is just to kind of get that going. And then you save the template and we're done. So we don't actually have to run the scan. We just need for Venari to be running in the background, because what's going on here is the Venari user interface is built on Electron so that it can run cross-platform, but it's actually making API calls to a local server which hosts the microservices which do the scanning. So all of the Venari editions have the same core scanner. This has one job node running locally on the machine, and that job node is actually going to drive the AutoMapper to do the exploitation and site mapping. Now that the Venari local server is running, we can switch into Burp and get the auto map process started. So I'm going to invoke the right-click context menu, select Start Auto Mapper, and I'm going to pick WebGoTo, which is the app we just created. And then we're going to switch it to the Target tab, and this is where the sitemap is going to start streaming in as the engine spins up. So I want to emphasize that you don't have to do what I'm about to do, but I'm going to demonstrate in Venari that there actually is something going on. So in this job tab, let's go to the beginning so we can see it again. In WebGoTo, inside of jobs, we've got a running job. So you can kind of see that the server that I mentioned before is actually running, and it should be producing a stream of discovery URLs and XHRs and things like that, as well as vulnerabilities kind of any second. So we're going to switch back to Burp and confirm it over there. So the fact that we're seeing this tree being built out means that it is going through the browser discovery and spidering process. I'm just going to click a few of these. And one thing I want to point out, so this is an automatically self-driving crawling engine and exploiter. So these results are going to be able to be used by Burp and all the other views that are very popular to work with this data and these traffic sessions, etc. But for right now, I want to point out that this is a completely logged in discovery process. So I'm going to switch back to Venari again just to demonstrate that. And you don't have to do this, but it's kind of nice to be able to use both tools at the same time. And the thing that makes that possible is that REST API I mentioned can handle the concurrency. So the auto mapper and the auto mapper and the Venari UI are both speaking to that REST API at the same time. So you can kind of see Venari doing its thing. And one trick I like to demo is in the browser view, we can kind of walk through the process and look at snapshots and see that we actually did get logged in. Here's the little user icon. So we're in a logged in state, so everything that we're collecting is the fully visible application. Switching back to Burp, we can now see in the sitemap view that we've got quite a bit more content, so we can click some of these nodes and expand them. Quite a lot of URLs have been collected. I can expand these out to kind of take a look. So we're finding a good amount of the site. Here's some of the other lessons like XEE, things like that. There are no issues yet. This scan typically takes between 45 and 50 minutes. It does a pretty good job of finding the vulnerabilities that are available on WebGoat, and we're going to do a little trick in a minute. We're going to fast forward into the future and look at the complete set. Okay, we're back. We've given the scan time to finish, and I've got some nodes expanded in the sitemap to show where vulnerabilities have been detected. We're going to go over here on the right and go through them, see a couple of examples. We're going to specifically look at DOM-based XSS detection and how these views help the tester out with meta information and proof that the XSS actually happened. And we'll end up looking at both the Venari UI and Burp to kind of really prove that. But let me walk through what's going on with this particular one that's selected. So this WebGoat Challenge 6 URL, if you look at the request, which is highlighted, you'll see a couple of things that are interesting. So here is the attack payload in this sort of pink-red color. There are some headers that are not really headers that are showing up here. So this x-venari-comment is really just meant to be helpful information, and this was not part of the original traffic, but it's put here in case there's anything like the document HTML URL that you need to look at, this kind of additional meta information. So the other thing that jumps out here is that this is an XHR request. So this is not asking for a full page resource, it's asking for some data back. So the page is already rendered, and we're going to see what happens. So if you look over here in the response, what these little markers tell you is that the original response did not contain the reflected payload or any kind of executable JavaScript, that happened during a later DOM snapshot after that XHR call completed. So this is just helpful metadata. This is not the original response at the top. This is generated DOM snapshot of the DOM at the moment in time when the XSS was detected. And we're going to scroll most of the way to the bottom to actually see where that showed up in the DOM. I I missed it. There it is. So if we look at this alert call in the script blocks, there's a randomly generated number here for tracking purposes. This one ends with 3810. We're going to see that again later. So I'm going to keep scrolling down and show more of the markers. When we get to the bottom of this, you'll see that the generated response ends here, and that was just the DOM snapshot. And after this little marker is everything that came back in the original response. And that's a little bit busy for the user to look at, but the data itself is pretty important. This was just JSON data coming back from WebGoat, letting you know that this lesson had actually been accomplished. So we popped the XSS, WebGoat gave us credit for it, but the actual DOM snapshot that detected the XSS came from Venari and was delivered through the AutoMapper integration. So we're going to kind of prove that by switching over to Venari and looking at the same vulnerability. So I've drilled into this job view. This is all of the findings. So findings are synonymous with issues. This is just nomenclature between two different tools being different. So if I look at this WebGoat Challenge 6, what I expect to see is some useful details. First is just a write-up of what this rule means and some information. Oops, I have the wrong one. Sorry about that. Same URL, different vulnerability. We went with the cross-site scripting vulnerability. So information about how the algorithm works. This is kind of the money shot here. This is a screenshot. If you look at the end, 3810, this is actually the code executing. So this is not a false positive. This really happened. And if you look at the traffic, you'll see what we saw before, which is we sent the payload in the XHR, and all that came back was a little tidbit of JSON. But if you look at this additional tab, Document HTML, what this shows you is the relevant snapshot when the vulnerability was detected. So this was the thing that got wrapped up in the generated markup. So AutoMapper did that to conform with Burp's presentation norms. Let's see if we can find the same piece of highlighting down here, though. Let me take a bit. There it is. So there's the script alert. There's the 3810. So we've kind of verified this three ways. We've looked inside the DOM snapshot. We've looked at the screen grab. And then we also saw the original traffic in Burp, too. So I'm going to switch back to that now. And we're going to look at a few more of the results. All right, we're going to look at just a couple more of these issues, and then we're going to do some comparative testing between how these are represented in Venari, if you choose to look at them that way, and how they're represented in Burp, because there are some constraints on how this information is presented, so we've tried to kind of translate that in a way that makes sense. The one that's selected now is a SQL injection verbose, and you can see in the highlighted request that this is the SQL injection payload, and if you look in the response, I would expect to see some kind of evidence. Yeah, here it is. So this is a SQL syntax error exception that's been caught. The actual table name was used and executed, so you can kind of tell that this is real as well. I will point out that in the advisory, we've got some information which matches up pretty closely with what the Venari Community Edition produces. However, for formatting purposes, we've just kind of put this into this view with a little bit of formatting. So there are details in here about how verbose and blind SQL work in Venari, and it's just useful information generally on background. So I wanted to point that out. This other category is improper exception handling. So there are errors popping and too much information is being disclosed. My expectation would be to see things like stack traces highlighted. So there you go. And there's a handful of these. There's the other exception. So at this point, I want to switch over and look at the sitemap itself and expand this to give it a little bit more room. WebGoat is a complicated site to get a good crawl on because of all the XHR activity. So what this sitemap demonstrates is we've gotten a pretty good crawl of WebGoat and really hooked into a lot of different areas. You can tell by the titles of these folders that we're inside of exploit lessons. See a lot of OWASP top 10 terminology in here, but expanded. So this is a pretty deep and wide sitemap. It just keeps on going. I'm not going to review the whole thing, but if you do the WebGoat scan of this yourself, I would encourage you to look at this at the end to kind of get a sense of all the good traffic that you're trapping, including the SHRs. And all of this is reusable by all of the other Burp tools. So I want to point out one other thing, which is I did a trick where I started an auto mapping process and then kind of went away for 50 minutes and then commenced recording when it finished. There's no constraint that you have to wait. So if results are coming in and the sitemap is getting built out, you can fully interact with this while the data is coming in. That's the strength of this integration, is that you're pulling live data from an API and there's another scanner process actually doing the crawling and exploitation. So that's about it for now. In the next section, we're going to review how all this looks in Venari and similarities and differences. In this section, I'm going to discuss the way that information is visually organized inside of Venari, just to kind of compare to Burp and then to show ways where there's extra information you can get at if you have interest in it. So this is just the scan we just completed in Burp, and I'm going to switch to the Minari view. I'm just going to kind of do a brief little walkthrough. So on this summary tab up here with the blue line underneath it, you see this panel in the lower right. These are basically the same vulnerability counts as Burp had as issue counts. Right here they're shown because if you were using Venari natively in this UI, you would be looking at this as a progress view to know, which engines were running and doing which amount of queued processing. But over on the right, you'd see things like how many times have I been logged in, have I been logged out, what are the summary of the vulnerabilities. But if you want to drill into these vulnerabilities, you can start right here on the Findings tab. Findings is just a generic word. It means the same thing as issue. And you see them all here grouped. So here are all the cross-site scripting. I'm going to change this number here so we can get a few more of them on the page. So we showed in an earlier section how to drill in and get the details about the screenshot, the traffic, the document HTML if there was a snapshot. There's interesting things like this is a YAML description of the actual sequence of browser event stream items that happen, which we call a workflow. This shows you how you get to that point to even be doing that fuzzing or inspection operation. So that's just one example. There's a couple more down here. I think we looked at the SQL injection verbose. Let's look at that one again. Same kind of thing, highlighting. This request and response views are split, so they're not on tabs. You can see them both at the same time, but these are the same informational views as in Burp. I'm going to get off of this tab for a moment and show you a little bit about the browser tab. And this is just a quick overview. We have a full tutorial online on how to look at the Venari results, but the browser view is a different kind of a sitemap. This is a series of click streams and event streams. When did we hover? When did we click? How did we get from one navigable location to another? What did the site look like when we hit that location? So you can see the click streams and hovers and keyboard events all kind of broken down in a tree. And this is very useful for diagnosing kind of the structure of the site and how the HTML interactions work. The more traditional, what you're probably used to, graph or tree view is up here in the traffic view. And it has a couple of interesting features I'll show you. So we have broken out the login traffic and anything that's a 404 or a custom, error not found page gets its own node. But you can look at the amount of content here and you can kind of see that we're covering the same lessons in the WebGo site. And it's very, very similar to the Burp sitemap. This data that underlies all this, that the REST API is drawing from, is basically, this is going to be an identical sitemap to what we put into Burp. There's extra information in these fingerprint tabs. I'm going to just show a quick view of some of the information you can get. This is the reflections. So when you put a piece of data in to a parameter or some part of a subpath or the content body, you might get that back in a reflection, either on the same request or another request response pair at a later time if it's some sort of stored probe. So these probes are all available in this view, and we can walk through them. There's interesting information like which region or HTML element did it get reflected into. There are two kinds. So the browser probes they're reflections that did not come back in the initial traffic, but some kind of browser manipulation and DOM mutation had to happen in order to see it. So these are kind of intrinsically interesting if you're doing things like pen testing and you want to find potential targets to try out better payloads on inside of Burp, for example, then you can get that information here. There is a traffic reflection view as well, and these are for any kind of payload that went into the request and came out in the initial response, or even if it was a redirected response. It was in the original wire traffic and it didn't require a DOM mutation. A lot of these other tabs like automation have to do with DevOps use cases and creating custom workflows. That's a little bit out of scope for this tutorial on using the auto mapper, but I just wanted to make you aware that there's a lot of good information here. This was a tutorial on iteration 1 of AutoMapper, and in the future, a lot of this other rich metadata is going to make its way into the Burp plugin.